Hello everyone, welcome to our YouTube channel Calculus Hub UPI Cairo. This video is a part of Chapter 5 Applications of Differentiation in Calculus 1 course. Title of this video is The Linear Approximation or Linearization. Here we will show how derivatives can be used to approximate nonlinear functions by linear functions. I'm Hisham Hosni Hussein, Associate Professor of Applied Mathematics. Prepare your notes, your pens, your calculator, and let's go. In summary, to clarify the idea of the linear approximation, let's agree first on a point. The line that best approximates the graph of a function f in the vicinity of a some point p is the tangent line to this graph for this function f at x equals to e, on condition that this f has to be differentiable at this point. On the other side, already we know that the equation of the tangent line is y equals to f of a plus f dash of a times x minus a. From this perspective, for the values of x near x equals to a, we can approximate the values for the function f of x by the expression f of a plus f dash of a times x minus a, which is the expression for the linear approximation. For practicing, find the linear approximation for the function f of x equals to cubic root of x at a equals to 1. This is the x coordinate for the point of tangency, and use it to find the approximate values for the cubic root of 0.95 and the cubic root for 1.1. Okay, so we have the target function f of x. This equals to the cubic root of x, which is x to the power 1 over 3. So we will create like a flow chart. Here we'll substitute with the point of tangency, with the x coordinate of the point of tangency. Here this a equals to 1, then f of 1 will be 1 to the power 1 over 3, which is 1. The second step is find f dash of x. F dash of x here will be 1 over 3, x to the power negative 2 over 3, and then substitute with the x coordinate of the point of tangency. Here replace x with a equals to 1 to get that in f dash of 1 is 1 over 3. Now collecting this f dash of 1 and f of 1 and write the expression of the linear approximation for this function at x equals to 1. The linear approximation expression here is f of 1 is 1 plus f dash of 1 is 1 over 3 times x minus the x coordinate of the point of tangency, which is 1. This is the first part of the question. The second part of the question is we need to find approximate values for the cubic root of 0.95. The cubic root of 0.95, this nearly equal to the linear approximation of 0.95. That equals to 1 plus 1 over 3 times x, which is here 0.95 minus 1, which is 0.9833 and so on. The cubic root for 1.1 nearly equals to the linear approximation for 1.1, which is 1 plus 1 over 3 of 1.1 minus 1. This equals to 1 plus 1.0333 to infinity. Find the linearization of the function f of x equals to the square root of x plus 3 at a equals to 1. The x coordinate for the point of tangency, and use it to approximate the numbers square root for 3.98 and square root for the value 4.05. Okay, so step 1, here we have a function. This is the function f of x, and this f of x equals to root x plus 3. Step 1, find f dash. Step 2, find f at the point of tangency. F at the point of tangency is f of 1. F of 1 here equals to root 1 plus 3, which is 4. So it's 2 at the end. The second path to follow is we need to find f dash of x. So here f dash of x will be 1 over 2 root x plus 3. This is step 1 in this direction. Step 2 is find f dash at the point of tangency. So f dash of 1 will be 1 divided by 2 times root 1 plus 3, which is 4. So it's 1 divided 4. Now f of 1 is 2 and f dash of 1 is 1 over 4. So the linear approximation expression for this function at this point is 2 plus 1 over 4 times x minus 1. So this means that the square root of x plus 3 has an approximate formula L of x, and this L of x equals to 2 plus 1 over 4 times x minus 1, which means that here would like to evaluate root of 3.98. Root of 3.98. This equals to root of 0.98 plus 3, which is the linear approximation for 0.98. That equals to 2 plus 1 over 4 x, which is 0.98 minus 1. This is 1.995. Another question, find an approximate value for 4.05. This equals to root 1.05 plus 3. This nearly equals to the linear approximation of 1.05, which is 2 plus 1 over 4, 1.05 minus 1. The final value is 2.01 125. Now use the linear approximation to estimate the given number, 1.999 to the power 4. This indicator that the function f of x here is x to the power 4. Here it's requested to find an approximate value for 1.999. The nearest value that can work as a tangent point for this 1.999 is in a equals to 2. So this means that we will find an approximate formula for this f of x equals to x to the power 4 with the point of tangency or near the point a equals to 2. Step 1, find f of 2. F of 2. This equals to 2 to the power 4, which is 16. So 1. 2 f dash of x is 4x to the power 3. And now substitute with x equals to 2 at the function f dash. So f dash of 2 will be 4 times 2 to the power 3, which is 32. This f of 2, this f dash at 2. So the linear approximation expression will be L of x equals to f of 2, which is 16, plus f dash of 2, which is 32, times x minus 2. Now it's requested to find approximate value for 1.999 to the power 4. So 1.999 to the power 4 nearly equals to the linear approximation of 1.999. Substituting with this value in the linear approximation, you will get 16 plus 32 times 1.999 minus 2, which is 15.968.